Dear students, we will discuss about the polynomials. Few more examples we will discuss now. It will enhance your thinking power and you can able to solve any problems. Okay. Now, if alpha and beta are the zeros of the polynomial x square plus 5x plus c and alpha minus beta is equal to 3, find the value of c. This c is unknown to this is known, a is known, that is 1, b is known, that is 5, c is unknown. This unknown is to be traced out or find out where alpha minus beta is given. But generally we know that if this is a polynomial, it's alpha plus beta. If roots are alpha and beta, then alpha plus beta will be minus b by a, not alpha minus beta. And alpha into beta will be c by a. It is c, a is 1, c. But it is one extra thing is given. Alpha plus beta is not given. Alpha plus beta is given minus 5. And alpha beta is c. C is unknown. Another data is given. Alpha minus beta is equal to 3. Since for this unknown, extra data is given. From this extra data, we can able to find the value of c. Now, but we know that a square plus b square plus 2ab, a plus b whole square, a minus b whole square, a square plus b square minus 2ab. This implies a square a minus b is equal to a square plus b square plus 2ab minus 4ab. This is equal to minus 2ab. Same. This implies a minus b is equal to plus minus root over of a plus b whole square minus 4ab. This formula is utilized here. So everything is known. Alpha plus beta is known. Alpha into beta is known. Therefore it is given and the value is given 3. Alpha minus beta is 3 given. So put this value here, solve the equation, you will get c is equal to 4. Then you can verify after getting c is equal to 4, you can also verify your result. So c is equal to 4. Now another question. If RT means it is in the px is a polynomial. Since RT is equal to t square is equal to minus t plus 3t square minus t cube. Its degree is, what will be its degree? It is not in final form because it is in a complex form. It is not purely ax square plus bx plus c. We have to first solve this. Every time there is t is common. If you take t common, then it will be minus t common. It will be t minus 3t plus 4t square. After solve, we are getting minus 1 plus 3t minus 4t square. Now the degree reduces to 2. Initially it was found that t to the power q. No, t is divided here. First try to solve this, then you will find this value. Okay, the answer degree is 2. If there is no t, if suppose it is no t is here, only 3 plus 3t square minus 4t cube divided by t, it will not be a polynomial because this, if you partial fraction 3 by t plus 3t square by t minus 4t cube by t, even though it is reduces to t square, it is reduces to 2, but it is 3 to the power minus 1. So negative power will not be a polynomial. Okay. A quadratic polynomial whose zeros are minus 3, minus 4 is, what should be the polynomial? We know that if the roots are given alpha and beta, roots are given alpha and beta, and whose zeros are minus 3, minus 4. So the equation will be ax square plus x square minus alpha plus beta x plus alpha beta. This will be the polynomial where the roots are alpha and beta. It is given that alpha and beta is this. So the equation will be, what will be the equation? Since zeros are minus 3, 4, then the polynomial is, we know previously, this, add this to plus into add the, multiply this to, this sign will be here minus, then finally it will be x square minus x minus 12. Since no such option is there, this option is no here. We cannot find this anywhere. Just a little bit you apply your conscience. Since no such option is there, we must keep in mind that we have not earlier that if any polynomial has a root x square minus x minus 12 has roots alpha and beta, if you multiply with any k, it will be the alpha and beta will be the roots, because if this will be 0, we divide this k 0, this will be 0 automatically. So you just multiply a number k, also satisfy the roots. If this has the root alpha beta, that is minus 3 minus 4, if you will multiply k, the same root, okay, also satisfy the roots, and we must keep in mind that k also satisfy the roots, only just multiply k. For any k belongs to R, it can be a rational number, irrational number, it does not matter, because when you will divide it equal to 0, if you divide this, k will be vanished, because this will be 0. K into something is equal to 0. That means this something is equal to 0. If you divide k here, it is 0. So no problem. So if we multiply k is equal to half, we are multiplying this, because you look here, there is something equivalent to this minus 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 minus, and the x square term is plus. In other class, if this is x square, it is plus, not minus. It is everywhere plus. It is 2 plus 2 times plus minus, not in this form. Only this seems to be in this form. If you try to multiply half, then what we are getting? This is the original or the one principal polynomial we think. If you divide by 2, x square by 2, x by 2 minus 12 by 2, this is equal to 6. So this will be the answer. So just you have to apply your conscience for 1 to 2 minutes, then we can guess which answer will be correct. Outright, just you do not put this one, this one, this one, because you look here, these two must be minus. X square is positive, x square is positive, these two are not minus. X square is positive, these two are not minus. X square is positive, these two are not minus. So all these things are cancelled. If this comes to be, you think that this may be the answer, but it is not in this form, then try to think yourself. But if you will multiply k, then it will be the same polynomial. It will be another polynomial, but the roots will be the same, alpha beta. Just you multiply half, you will get this one. So C will be the answer. If alpha beta are zeros of, if alpha beta zeros of the polynomial fx ax square plus bx plus c, then 1 by alpha square plus 1 by beta square is equal to, this is given. We have to find out this one. Nothing is given, only this is the standard form. It has the roots alpha and beta. You think that given alpha plus beta will be minus b by a, alpha beta is equal to c by a. It is the standard formula of summation of roots and their product. Now, then what will be the value of this? You think 1 by alpha square plus 1 by beta square. Just to solve this, nothing else. Only algebraic expression, you cross multiply, the LCM will be alpha square plus into beta square. It will be beta square, alpha square. Just I have changed the order. Alpha square plus beta square plus by this. And this will be a square plus b square is equal to, I have told earlier, a square plus a plus b whole square, a square plus b square plus 2ab. Then what will be a square plus b square? This will come to this side minus a plus b whole square minus 2ab. But then now alpha plus beta square, alpha plus beta square, alpha plus beta is known to us, alpha beta is known to us, alpha beta is known to us. Everything is now known to us. Nothing is now unknown to you. So you apply this b square by a square minus 2c by a, c square by a square. After simplification, you will get the result this. So B will be the exact result. So only the thing is that you have to arrange these things in mathematical way or algebraic way, then you are getting the solution. Similarly, if alpha and beta are the zeros of the polynomial 2x square plus 4x plus 5, then find the value of alpha cube plus beta cube. It is not in x square plus bx plus c. The a, b, c are known to you. So if you will find, first apply the formula of alpha cube plus beta cube in terms of alpha plus beta and alpha beta, because only the things are given to you. Alpha beta are the zeros. We can find out alpha and beta, or then from that we will find out, we will find out that from this we can find out alpha plus beta and alpha beta. These two things can be traced out from 2x square plus 4x plus 5, because this is the root of alpha beta roots of this. So alpha beta is equal to minus b by a, alpha beta is equal to c by a. Put the value, you will get this. So alpha plus beta, alpha beta is known to us. From this we will find out alpha cube plus beta cube, alpha cube beta cube in terms of alpha beta. But we know formula that a plus b whole cube is a cube plus b cube plus 3ab into a plus b. This implies a cube plus b cube equal to a plus b. So this term is to be taken out. Find out a cube plus b cube, take to this side. So a plus b whole cube, take 3ab, a plus b to this side. Just order is changed as we are wanting this. This should kept in left hand side. So in the similar way, alpha cube plus beta is equal to alpha plus beta whole cube minus 3 alpha beta, alpha plus beta. This is known to us, alpha beta is also known, alpha plus beta is known. So nothing is unknown to us. But alpha and beta are roots of this. Here if anyone is unknown, nothing, everything is known to us, because it is a fixed number 2, 4, 5. So alpha plus beta is equal to minus 4 by minus b by a, that is minus 2 alpha and beta is equal to 5 by 2. You put these two values here, just nothing else, only two values are here. Alpha plus beta whole cube minus 2 whole cube minus 3 alpha beta 5 by 2 into alpha plus beta is equal to minus 2. After simplification you are getting the value 7. Only some algebraic expression, algebraic calculation, simplification, only the formula to be used, what is a cube plus b cube, a plus b whole cube minus 3ab into a plus b. This formula is to be used. Why? Because you will apply all these formulas, 3ab plus a plus b. If you apply the detailed formula, a cube plus b cube plus 3 a square b plus 3 ab square, or you can say alpha cube plus beta cube plus 3 alpha square beta plus 3 alpha beta square. We are not getting beta square is not known to us. This value is known to us. This value is only alpha beta is known, not alpha square beta or alpha beta square. But if you are taking common, then you are getting alpha plus beta. Okay. So these things to be keep in mind. Question number 18. If the zeros of the polynomial are 1 and minus 1 and 5, which of the following will be that polynomial? If the zeros of the polynomial minus 1, 5, which of the polynomial? The same question, just what is the formula? Alpha plus beta x minus alpha plus beta x square minus alpha plus beta x plus alpha into beta will be the required polynomial. And in general polynomial will be in the form of, you have to multiply the previous way. In this case, we have applied k. In the same thing, you apply here again, it will be in this form. So here alpha and beta are minus 1 and 5 respectively. So one particular polynomial may be in the form of general formula, that is x square minus 1 5 plus x square minus 4x plus 5. But no such option are there. This option is not here. But the same thing, you remember, these two are minus, no here, no here. These two are minus, but it should be plus, but it is also minus. So it is meaning it cannot be satisfied. Only come to this. This is minus, this is plus and plus. If you take minus common, if this will be minus, if you take minus common, x square plus 4x plus 5. There is no mistake. So this will be the answer. Okay, just a little plus minus calculation, imagination, no extra calculation or anything is necessary. Only k is minus 1 is multiplied, k is minus 1, written here, k is minus 1. But outright do not answer this or this, just think a little bit. Okay, find the zeros of the quadratic polynomial x square minus 3x plus 2. X square minus 3x plus 2. X square minus 3x plus 2. With the help of the graph. How will you construct a graph? In this way, you come to this by the process of factorization. Prior to going to the construction of a graph, you may create some mistake. Just to find out by your mentor within 1 or 2 minutes what should be the roots. X square minus 3x plus 2. By factorization, x minus 2, x minus 1 is equal to 0. Then x is equal to 2 and 1. 2 and 1 must be a point. 2 and 1 must be 2 and 1. Here it touches the x-axis and the coordinate of x. Okay, that will be the roots of the polynomial, where y is equal to 0. Now how will you draw the graph? Come here. X, fx is equal to or fx or px. It may be px or fx, doesn't matter. X square minus 3x plus 2. It is x. This is x minus 2, x minus 1 is equal to 0. 0 is of the 2 and 1. So you always I have told that take instead of 2, you take instead of 3 or 4, you take 5 points. Then it will be easier to draw the 5 or 6 points. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 points. Then it will be easier to draw the by pen and pencil. Okay. So if you take 2, it will be 0. If you take 1, it will be 0. If you take minus 1, it will be 6. So my points are traced here. Then the graph will be in this way. So where it crosses the x-axis? At this point and at this point. It touches the x-axis. So what are the coordinate of this x coordinate is 1. Its x coordinate is 2. So what are the 2 points? The zeros 1 and 2. Where it touches the x-axis means y is equal to 0. X is equal to once 1, the other time 2. So 1, 2, 1 point, 2, 0, 1 point. So what are the roots? 1 and 2, x coordinate. You trace the x coordinate. Where the also you got this y is equal to 0. What is the value of x? X is 2 and 1. From this you also know what are the roots. 2 is a root, 1 is a root, because y is 0 here. Y is means fx means px, that is 0. Okay. If a quadratic polynomial curve in the shape of a semicircular circle is shown below, then the equation of the curve is given in this way. So what are the points? The points of the semicircle. Semicircle means only from this to this. So it is 2, it is minus 2. What will be the d? D is totally 2, 2, 4. Or the what is the r? This is r. R is equal to 2. It is also 2. Now the roots are, what are the roots? Where it touches the x-axis. So the roots are 2 and minus 2. 2 and minus 2 are as seen from the figure, as the semicircle touches the x-axis at point minus 2 and 2. So the general polynomial is in the form of, we have known that alpha plus beta. x square minus alpha plus beta x plus alpha into beta. This will be, this is 0. X square minus 4, and we know that the equation of a circle is x square is equal to r square. That is the equation. It is now, is not it? X square minus 4 is equal to 0 means x square is equal to 4. Okay, r square, r is 2, x is equal to 2 plus minus 2, r is, so the distance will not be a negative, so ultimately r will be 2. It is a circle, and therefore the equation to the semicircle will be, what will be the equation to the semicircle? Will be x square minus 4 divided by 2. Circle equation is this. Semicircle equation will be divided by 2. This is x square by 2 minus 2. 4 by 2 is 2. It is by partial fraction. But no such option is there. In this case, no such option is there. Just to change, you can multiply any k. So multiply it by minus 1. Minus 1 is minus x square plus 2. So D will be the answer. Okay. Since we arrive at x square by 2 minus 2 and there is no such option, and if another was none of the above, out of the curiosity do not opt that the option, rather verify by multiplying with some k belongs to R and thereafter take the decision. In the above example, k is minus 1 is multiplied and got the option D. Outright we do not say that there is no such option or no such option is fit to this answer. It is not genuine. Always you try to multiply some k, either plus 1, minus 1, any fraction, whatever that may be. If you then you decide whether there is any option, correct option or not. The polynomial x minus a, where x is greater than a, is a factor of the polynomial qx, that is equal to 4 root 2 x square minus root 2, which of this is a polynomial whose factor is x minus 1 by a. Qx is this polynomial and it is a factor x minus a. Okay, given x minus a is greater than 0, is a factor of qx. It is written factor of qx. Qx is 4 root 2 x square minus root 2. So x is equal to a is greater than, is a root of qx is equal to 0, because if x minus a is equal to 0, if you are taking that, it is a factor of qx. I will tell you that x minus a into px is equal to 0. This is equal to qx. X minus 1 is a factor of qx. If this will be 0, either px will be 0 or x minus a will be 0 or both will be 0. Both will be 0, it will not a polynomial, so no question arises. So for the time being, let us take either this will be 0, this will be, I have told earlier, a into b is equal to 0 means either a is equal to 0 or b is equal to 0 or both are 0, but both are 0 in polynomial. It is not, we are not taking that, because if both will be 0, there will be no polynomial at all. So take any one. If x minus a is equal to 0, this implies x is equal to a. X is equal to a, it is written here. A is greater than 0, is a root of qx is equal to 0 automatically. This implies, why it is given, I will discuss later on. For root 2 a square minus, because we are putting the value of, instead of x, we are putting this one, a. We are putting a, x is equal to a. This put x is equal to a square. No x is further. So this implies root 2 4a square minus 1 is equal to 0. This implies a is equal to plus minus root 2. Just I have omitted 2 or 3 steps. Okay, since a is greater than a has only one admissible value. It is plus minus half, but a is given to be greater than 0. So a is minus half is ignored because that is not possible. So only the possible value is a is half. in the new polynomial, x minus 1 by a will be a factor. Because that if this will be a factor, now we have to create a polynomial x where the factor will be x minus 1 by a. Now, in the new polynomial, x minus 1 by a will be a factor. So, this implies x minus 2 will be a factor by x minus half. X minus 1 by a will be a factor. So, x minus 2 will be a factor. The implies x is equal to 2 will be a root of the new polynomial. So, when the new polynomial, it will be a factor, x minus 2 will be a factor, because x minus a, this implies x minus half will be a factor. This implies 2x minus by 2 is a factor. This implies 2x minus 1. So this implies x minus 2. Why x minus 2 is a factor? It is written here, which is a polynomial whose factor is x minus 1 by a. In the new polynomial, x minus 1 by a will be a factor. This implies x minus 2 will be a factor, because 2 is x minus 2 will be a factor, implies x is equal to 2, which will be a root of the new polynomial. Now a is equal to this, a is equal to half. Now in new polynomial, which factor will be x minus 1 by a will be factor. This x minus 1 by a means x minus 1, a is half, so x minus 2. So x minus 2 will be a factor, implies x will be 2a, root of the polynomial. So just to little exercise, you can find out what will be the polynomial, which polynomial will satisfy that x will be 2. If x will be 2, this will not 0, this will also not 0, this will not 0, everything is positive. Here it is 2 to 4 for 8, not 0, it is not 0, only this is 4 plus 2, 6 minus 6 is 0. So this B is correct, because x minus 2 will be a, x minus 1 by a means x minus 2 will be a factor. It is just a remodeling of the question. Once it is under x minus 1 is a factor of the polynomial of q, this, and another factor, and you have to trace out another polynomial where the factor will be x minus 1 by a. Okay, 1 by a is traced from here. Which of the following could be the equation of a parabola, this and this? For any parabola, the equation must be in the form of a quadratic equation. We know that earlier, degree 2, it represents a parabola. In the form, standard form is x square plus bx plus c is equal to 0. But in A, after simplification, x square of both, you just look here. Here is x square, when you square this, it will be a square minus b square, a square plus b square minus 2ab. It is a square plus b square, this x square, it will cancel out. So no term will be there, x square only starts from x, no quadratic. If you take this x and x, it is no quadratic. If you take this, it is no quadratic, it is cubic. Come to this is only quadratic. So D is the correct answer. Only to put you into confusion, this aspect is given. Someone think that it is also power 2, but no. After simplification, the both side of the x square will be cancelled out. Okay. If the graph of polynomial intersect the x-axis at only one point, then what will happen? It only one point. It is also crosses at one point. It also crosses here one point. This is a straight line. This is a parabola. Is always a linear polynomial, means straight line. Always. No, in this case it may happen only if the x at only one point. It crosses at the only one point does not mean that it has only one root, because whenever in this case, if you some other way, another equation is like this, another equation is like this. It means when two different roots, but here the two different roots coincide at one. The same roots twice. So it does not mean that it is touches the x-axis at one point, means it is only one root. The one root may be twice. It will be treated as two roots. So can be a quadratic polynomial, parabola or circle. Maybe parabola or circle, both are okay, no problem. Can never be a quadratic polynomial. Can neither be linear nor quadratic polynomial. Which will be correct? From the graph, it was noticed that in case of a straight line linear polynomial, it crosses the x-axis at only one point. Okay, is always a linear polynomial. Always, it is not possible. Also, in case of a parabola, when the roots are equal, which touches the x-axis exactly at one point, but it has two roots, same two roots. So, B is the correct option. Why? Can be a quadratic polynomial. It is always linear. It is not possible. At this case, it is not linear. Can never be a quadratic polynomial. Yes, in quadratic polynomial, it is possible, because if two roots are same, this is also not possible. This is not possible. Can neither be linear nor quadratic. It is also not possible, because in quadratic it is also possible. So the B is the correct option. X square plus b by x plus c is not a polynomial, as b by x is b to the power b into x to the power minus 1. It is not a polynomial. X is power minus 1. Okay. So all the questions are completed related to polynomials, and after 2 or 3 chapters we will discuss some case study questions and assertion region questions. For this time it is completed. Thanks to all. Okay.